the spanning tree. So by using this spanning tree, it is possible for us to select the minimum path if you have a multiple path between source to destination. So that is why we have created a spanning tree. And this spanning tree we are going to use in a routing protocol called as a path vector routing protocol. Yes, Rupashri, any doubts? Can you just mute yourself? Okay, so we will be using this spanning tree algorithm, and if you see this spanning tree algorithm, so we mainly use this spanning tree algorithm in order to update the path vector routing table. Okay, so generally this spanning tree algorithm, as we discussed in the module number 3, it is used to avoid the looping problem which may be existing in the given network. So in the last class we discussed about this spanning tree looping problem. So here you can see here in the given diagram, so what we have, there is a loop has been created between the terminal B, C, D, E. So in order to avoid this looping problem, so we have used the spanning tree. So by the use of this spanning tree, we can avoid the looping problem. So the multiple path between the source and destination can be avoided by the use of this spanning tree algorithm. So now how you can create this spanning tree algorithm? So this spanning tree algorithm, it is similar to how we have created is a distance vector routing algorithm. Okay, so how we have done in distance vector routing algorithm, for each node, so at a periodic sequence of time, we will be getting a routing information of the neighboring nodes. So based upon the routing information about the neighboring node, we were able to update the route, that is a distance vector from each node. Okay, so now each node what it does is, so after creation of initial path vector, it sends to all its immediate neighboring nodes. Okay, so means what? Once the network has been created, that is when the network, when the node has been booted, means it has been identified in the network. Each node what it does is, it creates the initial path and it sends that path to the neighboring node. Okay, so each node what it does, so after receiving the path vector from the neighboring node, it updates its path vector by using the equation. So what is that equation? So we have used the Bellman-Ford equation, right? If you remember, we have used the Bellman-Ford equation in order to find the minimum path between the source to destination if you have an intermediate node. So by using the Bellman-Ford equation, we can able to create the path with the best identified path between the source and destination. Okay, and based upon that, so we can create the path vector for each node. So you can see here initially when a node has been created. Okay, so when a node has been created, there is a link is there from A to B. When a node has been, network has been created, you can see from A terminal, a node has been created. So there is a path is there from A to B, there is a path, and B to A path is there. Therefore in the table, so we have a path from A to B and B to A. And after that we come to a conclusion that again B has been connected to C and D. So when B has connected to C and D, now we need to consider the path vector for the B in the network. So you can see the path vector for B in the network. You can see from B to A there is a path. Therefore we have written for the A we have a B to A, and for the B to B there is always, there will be a by default path will be there, and from B to C there is a path, and B to D there is a path is there. So this path vector will be updated once the nodes are booted within the network. So now you can see in the node C. See the node C now, that is the difference where you can able to see here. So the information which is related to node A, it is not available for node C. Therefore you can see here the data communication between node C to node A, it is nil. Whereas from B to C it is there, therefore the path has been written B to C, and C to C by default path is there, and C to D there is a path is there, and C to B there is a built-in path is there, and for the E as we there, it is a path is there. Okay, So this is how we can create a path vector for the node C. Similarly for the node D, since it is not directly connected to A, so therefore there is no path is existing between D to A, and there is a path with B, there is a path with C, and there is a path with E, and which is corresponding to E. So based upon that we will be creating a spanning tree. Okay, so now when we creating this spanning tree, after creating the spanning tree, so what we need to do is, so we need to update the path vectors corresponding to the neighboring path vectors. Okay, so how it does is, so you can see here, when a node receives a path vector, that is when a node receives the path details of the path B, that is a node B, it will update. So how it will update? See, there is a link is there from B to C. Since in my path there is no link is there, so therefore what I can do is I can reach from A to B, and from I can reach from B to C. So therefore there will be a path will be created by using a path vector upon reception of the path vector of the node B. So the node A, what it does is, upon reception of the path vector of the node B, the link will be created for node C through via node B. Similarly, the link will be created through via node D, but whereas for the node E, there is no link will be created in a node A. Why? Because since C is E does not connected to B directly. Okay, so this is how the path vector will be updated upon reception of the neighboring nodes spanning tree algorithm. Okay, so in order to use this, or in order to highlight that path vector training model, so what we have done is, you can see this is the path vector algorithm what we will be using. So initially the path vector routing algorithm, the name of the function what we have created is, we have created a path vector routing algorithm, and we are assuming that there are n number of nodes are there, and for this n number of nodes, first we need to establish a network. So for that we have created a network we have established, and depending upon the connectivity of the particular node with the neighboring node, so we will initialize the path vector based upon the direct connectivity with neighboring node we will be testing. So after initializing that, after the node has been booted, so each node will have its own path vector. So once the path vector has been initiated, or once the path vector has been created for all the nodes, then these path vectors has to be updated with the neighboring nodes. So what they will do is, they will send the path vectors of their corresponding node with the neighboring nodes who fall under the communication range of the different nodes. Okay, so let's say the path, for the example in the previous case what we have done, see the path B, that is a node B, it comes under in the provision of the node A. Therefore, the node B will send its path vector details to node A. So after reception of the path vector details from node B, the node A will update it. How it will update it? So if there is no path is there from one node to, that is from node A to node C, for the example what we have taken. So since there is no path is established in a node A, upon reception of the path vector from node B, there is a link can be established from B to C. So if it assumes that okay, there is a link is there, so I can able to establish a communication path from A to B and B to C. Similarly with respect to D, the same thing will happen. So there is a path vector is there, and there is a link is there from A to B already, and I need to create, or I need to include a node which will be generating a next link. It will enable us. Okay, so based upon that, a link will be created from A to B and B to D will be created. So this is how the path vector will be updated, and we will be using this equation, that is, this is a Bellman-Ford equation what we have used in the distance vector algorithm. So the same Bellman-Ford algorithm we are going to use, and in order to avoid the that is a path from a particular node to the corresponding node, so we are going to avoid, that is a path which is included myself path we will be including. So therefore we will be avoiding this. So apart from that, so once the node receives all the neighboring path vectors, it will update it. If there is any change in the path means, then again that modified path vector will be received, will be transmitted to the corresponding neighboring node. The neighboring node will update upon reception of the updated path vector. So this is how the path vector algorithm will works in the routing principle of link state routing algorithm, or also we call it as a unicast routing algorithm. So the next one is the unicast routing protocol. So what do you mean by unicast routing protocol? As I said you, unicast routing protocol which you are going to use an internet connectivity. So with the use of this unicast, that is a internet connectivity, we can able to establish a larger domain networks. So therefore, such a type of routing protocol we are going to call it as a unicast routing protocol. Okay, so when you want to use this internet facility for the routing table, so you need to define what is the domain you are going to use it, because the internet will operate, as I told you, in a two different methods. The one we call it as a circuit switching method, and one more we call it as a packet switching network. So you need to domain, you need to specific, and what is the domain in which you are going to do the routing operation, it has to be clearly indicated, and what type of message you are going to establish, and what are the routing devices will fall under your communication. So all those has to be understood when you want to go for this unicast routing algorithm. So there are different varieties of unicast routing algorithm are there. So among them, so we will be studying three important routing unicast routing algorithm. One we call it as a routing information protocol, that is nothing but RIP routing protocol. Okay, so routing information protocol, RIP routing protocol. So this routing algorithm, it is based upon the distance vector algorithm what we have studied. The second one we call it as a open shortest path first algorithm. The second one we call it as a open shortest path algorithm. It is based upon the link state routing algorithm what we have studied. And the one more we are going to study, that is nothing but a broader gateway routing protocol. So by using these three protocols, we can able to establish a routing of the packets over the internet. Okay. So this is the internet structures. So how exactly the internet has been built. So from the customer network, it will be given to the network provider, that we call it as ISP, internet service provider. So from the internet service provider, it will be connected to the backhaul network, that is PST network will be connected. So from the PST network, it will be connected to the peer-to-peer entity, and from the peer-to-peer entity, the network provider will customize its network based upon the number of service that the user is providing to its subscriber. Okay, so this is how the internal architecture of your internet will be working. Okay, so here the major part of the structure is, so how best the internet service provider, they will organize their data, and how the density of the users will be divided among the networks, that is between the customer network to the one customer network. Okay, so this is how it will be connected backward to the PSTN system, that is a public switch telephone network. So how you are going to incorporate, or how you are going to do the compatibility from PSTN with the network provider, that has to be understood when you go for the unicast routing protocol. So therefore it is necessary for us to understand this internal internet. We have used not only one backhaul network, so there are several backhaul network we have provided. So these backhaul network will provide a private communication for the different companies. Okay, so based upon the global connectivity. Okay, and these backbone network will be created by using some peering points, which allows the connectivity between the backhaul network. Okay, you can see here the peering points what are there. So by using this peering network, it allows one or two different backbone network to be connected, so that it can reach to the global entities. As the lower entities, as in case of lower level, some network providers networks will be connected to this backbone to provide internet services to its customer. So here network provider is nothing but ISP, that is the internet service provider. Okay. So this is the architecture of your internet structure. Okay. So here you can see here the internet structure. It is like a tree structure. So this tree structure, it is having a single backbone with a single backbone with multiple backbone structures we can have, along with the different private corporations can be incorporated. So this is a general architecture what we are going to use in the today's internet world. Okay, and we have used some backbone network as we discussed. So by the use of this backbone network, we are connecting through the use of peering network. So by connecting or by using these peering points, the backbone network can be connected so that we can reach to the global entities. So the next one we call it as a hierarchical routing protocol, or it is also called as a hierarchical routing protocol. So why it is necessary this hierarchical routing protocol is, see, whatever the internet we are using today, it is made up of large number of networks and routers that are connected to them. So whatever the network we have created today, it is made up of large number of the networking devices along with the networks which are connected to them. Okay, so by the use of single routing table or by the use of single routing algorithm in the network, that is in the internet, it cannot be possible for us to provide a routing information in the internet structure. Means if I am going to use only one routing algorithm in the internet structure, means it is not possible for us to provide a routing information or routing of forwarding the packet from one node to another node which are geographically far apart. Why? Because of the large number of devices which are formed in the creation of the internet structure. Okay, so that is why, so we go for different routing algorithms. So the routing algorithms, it may be an intra-routing algorithm, that is autonomous system, or it may be an inter-autonomous system, or it is called as a inter-autonomous system, we are going to call it as. Okay, so based upon that, your internet service provider will be created, or it has been nomenclatured, or it has been renamed as a hierarchical routing algorithm. So in this hierarchical routing algorithm, so one network will be will act like a primary node. From the primary node, a secondary networks will be created. From the secondary node ternary network will be created. Okay, so based upon the geographical location and based upon the type of networking devices what we are going to use and the density of the network what we are going to use. So based upon that, this internet structure we are going to differentiate, or we are going to provide a routing information based upon this hierarchical routing principle. In the internet, that is in the internet network, a single protocol cannot be used. A single protocol cannot be used in order to provide a routing or forwarding of the packet. Why? Because there will be two reasons why it is not possible. Is the first reason what we call it as, it is a stability, that is a scalability problem. So because of the scalability problem, we cannot able to provide a single routing algorithm in order to do the data transmission. And one more is the administrative issues. Why? Because of the nodes which are geographically far apart, if they want to do the communication means, then we have divided our universe based upon the countries and based upon the cities. So therefore, the administrative issues, it is not possible for us to employ a common rule when you want to do the data transmission because of the geographical far apart distances and what we have created. Okay. So in the case of scalability problem, so what you mean by scalability problem is the size of the forwarding table becomes huge. So if you use only a single protocol, internet protocol means, then what happens is the size of the routing table. Why? Because since the large number of nodes are there, so if you want to do the data transmission from source to destination means, then the routing table will be a very huge process, or it will be having a large number of data. So it is to process the large number of data, it will be very difficult for us to do it with the available communication devices. So because of this, the scalability problem will be arises. And the second one what we told is the administrative issues, which is related to the administrative authorities. So as I said, since our universe is being divided into countries and continents and different states, so the data rates or the existence of the architecture which is related to internet, it is also changes. So therefore we cannot have a common billing system over the universe. So because of that also, it is not possible for us to provide a single routing information for the internet network application. Okay, so therefore what we have done is, so we have come up with a top to bottom approach, that is nothing but the division of this unique common routing protocol into layering architecture, or with the use of layered architecture we are going to implement. So among them, the first one we call it as a hierarchical routing algorithm. So in this hierarchical routing algorithm, so what we call it is, each the internet service provider, we call them as a autonomous system. So each internet service provider, we call them as a autonomous system. So what you mean by this autonomous system is, so each this autonomous system will run on a unique routing protocol. Okay, and these routing protocol will meet their needs, but the global internet runs will be a different one. Okay, so this in the internet service provider, what they will use their own routing protocol in order to satisfy or in order to meet the design requirements of their each individual routing. Okay, so that is why we will be using this hierarchical routing algorithm. Okay, and in this routing algorithm, the routing protocol which you are going to run on each autonomous system is referred as an intra-AS routing protocol. So the routing protocol which you are going to run on each autonomous system, that is nothing but internet service provider, we call it as an intra-autonomous system. And with the use of this intra-autonomous system, we can able to create, or we can able to establish a routing protocol for the interior gateway protocol, that is nothing but IGP protocol, whatever we have read, right? So we can able to create this global routing protocol by using this intra-AS routing protocol. Okay, and presently, as we said, there are two common intra-domain routing protocols. One we call it as a RIP protocol, and one more we call it as a OSPF protocol. Okay, so based upon this we are going to study so how this routing protocol will be takes place. So we were discussing about this hierarchical routing protocol. So this hierarchical routing protocol, as I said you, it is will be divided into intra autonomous system and inter autonomous system. Okay, and each this internet service provider, so we call them as a autonomous system, and this autonomous system, it responsible for managing the routings and the router under its control. So if there is any fault occurs within the network, means then the each internet service provider as a whole held responsible in order to rectify that, and in order to maintain that the network will not go into a congestion method. Okay, and in order to provide this, in order to identify, or in order to give the identity for each internet service provider, we are going to give autonomous number that we call it as a ASN. So ASN is nothing but an autonomous system number. So each that is a each service provider, so we will be allocating the 16-bit unsigned integer, so that will identify so which is the internet service provider over the network. Okay. So this is what it's all about, your autonomous system. So in the when we talk about this autonomous system, so we mainly do three important operations which is related to your autonomous system. So the first one we call it as a stub AES. The first one we call it as a stub AES. So what do you mean by stub AES is nothing but when a AES is connected to another AES, so this combinations we call it as a stub AES. So in this case what happens is that the data traffic can be either it might be initiated or terminated in one stub to another stub. Okay, so the data cannot pass through it. So in the case of stub AES, so it is just used to do the connection of one AES to another AES. So the data either it can be initiated or it can be terminated, but it cannot be passed over the two AES system. So one of the simple example is, so as we studied in the data transmission, right? So one can act like a source and one more we call it, can act like a sink. So in the CCN, when we are solving, when we are using in the lab, so what we done, so we have created one LAN topology. So when we create a LAN topology, so we have created or we have established a link from one LAN to another LAN, and we have introduced the error node between the one LAN node to another LAN node. So one we designated as a source and one more we designated as a receiver. So if I want to designate as a source means, then what we did is we have attached the TCP agent, and for the TCP agent, what is the data type we have created? We have created a data type called as a file transfer protocol we have created. So with the use of this file transfer protocol at the source, so it is necessary for us to create a receiver as a sink. So therefore we have created a TCP sink. So with the use of this TCP sink, it is possible for us to receive the data from the TCP agent. So that we can call it as a stub AES. There is one more autonomous system, what we are going to call it as a multi-homed autonomous system. So in multi-homed autonomous system, what happens is, so we can have more than two autonomous system. Okay, so if we are connected more than two autonomous system means, then it is called as a multi-homed autonomous system. But it also does not allow us to do the data transmission to pass over it. Then what is the use of this multi-home autonomous system is, so when we want to do the debugging of the network, or when we want to do the means the security issues of the network in the internet service provider, if you want to do it, then this stub AES and multi-homed autonomous system will play an important role in order to do the debugging operations if any fails occurs in the network. So therefore we are going to use this stub AES and the multi-homed network. So one of the simple example what we can give for this multi-homed network is, so some customers of A, they may use services more than one network provider, but their policy does not allow data to be passed through them. So you can see here, when each customer, if they are using two or more different network service provider means, in such a cases we need to see, so what are the policies which has been governed between the network service provider with the customer. So based upon that, we can able to allow the data transmission between one network service system to another network service system. So there we can make use of this multi-homed AES system. And one more we call it as a transient AES. Transient AES, it is nothing but it is connection from one or more another AES, and it allows the traffic to pass through it. So in such a cases we call it as a transient AES. So as the name indicates, so if you want to have the data transmission between one AES to another AES means, so instead of stub AES, so we can go for this transient AES system. So with the use of this transient AES system, the providers of the network, they can be connected to the backbone network. So therefore these transient system are the good example for the backbone network which can be used in the internet service provider activities. Okay, so this is all about your hierarchical architecture. And the next one is, so we will be studying the three important unicast routing algorithm that we call it as a, first one is routing information protocol. So that is it is called as a IRIP, that is routing information protocol. So this routing information protocol, it is mostly used in the intra-domain routing protocol. It is mostly used in the intra-domain. So means what? From one domain to another domain, if you want to do the format transfer of data, then we are going to use this intra-domain routing protocol. And this intra-domain routing protocol, that is nothing but a RIP protocol. It is based upon the distance vector routing algorithm. It is based upon the distance vector routing algorithm. And this distance vector routing algorithm, which was initially designated or which was initially called as a Xerox network system. This RIP protocol, it was initially called as a, or it was being initiated with the Xerox network system, and which was derived or it was developed based upon the Unix platform. It was developed based upon the Unix platform. So then now we are going to see how this routing information protocol will transfer the data from source to destination, be able to see. So for that, first we need to see the hop count. Okay, so what you mean by hop count is, so let's say I have a source and destination. So if I want to transmit the data from source to destination, if it is not possible for me to transfer the data from source to destination directly, means then we are going to use an intermediate node for the data transmission or for the data forwarding of the packet from source to destination. So the number of intermediate nodes which we are going to use in the data transmission, that we call it as a hop count. Okay, so we are going to use this hop count in the implementation of this routing protocol. Okay, and we have made use of this distance vector routing algorithm in order to create or in order to calculate the hop count which we are going to calculate in order to establish a route between source to destination. Okay, and as we are using this distance vector routing algorithm, the cost which is associated between the nodes, so that also be considered during the routing state information or during the creation of the routing vector. And this routing vector, whatever the cost we are defining, so it is defined based upon the router and also the network in which the destination host is located. So we are going to create this, or we are going to assign this cost based upon the router, what the router we are doing, we are using, and also the destination to which the host has been connected. So based upon that, we are going to assign the cost for each distance vector routing table. So this is how the hop count we are going to establish in the case of RIP protocol. So you can see here, in this RIP protocol, the maximum count path which can be seen is as the 15, which means that 16 is considered in an infinity loop, which means that 16 is considered in the infinity loop. And see, there are 15 hop counts are there from here. So why? Because one hop count for the N4 and two hop count for the N3 and N6 and three hop for the N2 and N3 and 6. So means for 3 into 3, 9, 9 plus 4, 13, 13 plus 1, 14. So 14 hop counts are there in order to reach from source to destination. Okay, so this router, it is serving for N2, N3 and N4. So therefore it is having a 3 hop count, and the router 2, it is serving both N3 and N4. Therefore it is having a 2 hop count, and the router 3, it is serving only one destination hop count. So therefore the hop count is 1. So based upon that, we can say that there are 15 hop counts are there from source to destination. So since 15 cannot be treated as a binary number, so therefore we go for a 16 hop count between the source to destination. So this is how we are going to calculate the hop count in case of RIP protocol.